So we'll be looking at sequence and series. Sequence and series. What is a sequence? A sequence is the arrangement of numbers in a particular order following some rule. We said a sequence is the arrangement of number in a particular order following some rule. Alternatively, I can also give you a different definition. We can say a sequence is a set of number which follows a definite order. It follows a definite order, so they are the same thing. Then we said that the number in the list are called the terms of the sequence. The numbers in the list are called the terms of the sequence. For example, if you take 2, 5, 8, 11, 14, 17, the values I just mentioned are terms of the sequence. And what makes it move in a definite order, if you watch carefully, a particular value was added to 2 to give us 5. That same value was added to 5 to give us 8. The same value was added to 8 to give us 11. And that same value, constant value, was added to 11 to give us 14. And that same constant value was added to 14 to give us 17. So I will leave you to think about that number. Don't just take time to look at the number 2, 5, 8, 11, 17, 14, and 17. So consider the number that was added. There was a particular constant that was added that brought about those values. So each of the value we have here in our node is referred to as number of 10 or 10. So now we'll go to sequence. So a sequence can either be finite or infinite, which some persons call finite. So when we say a sequence is finite, what does it mean? It is finite when it has a fixed number of terms that can be counted or has an end. Sequence can be finite when it has a fixed number of terms that can be counted or has an end. Infinite sequence consists of countless or endless numbers of terms. Take note. Infinite sequence consists of countless or endless number of terms. If you look below, you have under the finite or finite sequence, you have 2, 4, 6, 8, 10, and then the last value there on our term is 50. So if you look carefully, the last value is 50. Then, but if you look the other way around, looking at the second example, which is under infinite, we have 2, 4, 6, 8, 11. If you look at 6, after 6 you have 8, 10, 11. And then if you look carefully, there are dotted lines there. Those dotted lines, those of you who study English, note those dotted lines are called ellipses, indicating continuity. The dotted lines are what? We call it ellipses in English, which indicate continuity. So for example, I'm counting 1, 2, 3 to 100, and probably I don't want to state 100, and my values, they say count all the numbers you know on earth. You know you can't count all. Even if you get to million, you have to continue to get to billion, to trillion, and so on and so forth. So how do you do this? You can actually count 1, 2, 3 to 5, and then use dots to tell us that there is continuity. Those dots, we call it ellipses, which indicates what? Continuity. Take note of that. And then remember, our topic is space is targeted towards two things: sequence and series. So what is series? Series is the sum of sequence. Take note, that's just a brief definition. That series is simply the sum of the sequence. Take note of the terms of a sequence. Rather, series is simply the sum of the terms of a sequence. For example, we took our sequence before. We said we have 2, 5, 8, 11, 14, and 17. By the time I add up all my terms, that leaves also what? Series. So if you have terms and you add up the terms, it becomes series. So the difference between sequence and series is that sequence has to do with terms, number of terms, and series has to do with the sum of those terms. So when you add up terms, it gives us series. But those terms on their own gives us sequence. So take note that series is simply the sum of the terms of a sequence. For example, you have 2 plus 5 plus 8 plus 11 plus 14 plus 17. This was what we call series. Then quickly, let's look at types of sequence. Number one, we have arithmetic sequence, also known as arithmetic progression. Back then, you must have heard of AP. That's another word for arithmetic sequence. We have arithmetic sequence, also known as arithmetic progression. Then secondly, we have geometric sequence, also known as geometric progression. Geometric sequence, also known as geometric progression. Then number three, we have Fibonacci. Take note, Fibonacci sequence, which some people call Fibonacci. Some people call it Fibonacci sequence. We have Fibonacci sequence. We also have harmonic, or some people call it harmonic sequence. So take note, we said arithmetic sequence, also known as arithmetic progression, AP. Number two, geometric sequence, also known as geometric progression, GP. We have Fibonacci, or I said some people call it Fibonacci sequence, also known as FFP, which is Fibonacci progression. Then we have harmonic sequence, also known as harmonic progression, HP. Quickly, we're going to be looking at arithmetic sequence. What is arithmetic sequence, also known as arithmetic progression? What is arithmetic sequence, also known as what? Arithmetic progression. Arithmetic sequence, also known as arithmetic progression, is a sequence consisting of terms gotten by adding or subtracting a constant number from the preceding term. I take it again. I say arithmetic sequence, also known as arithmetic progression, is a sequence consisting of terms gotten by adding or subtracting a constant number from the preceding term. In arithmetic progression or arithmetic sequence, the difference between successive terms or consecutive terms is a constant, or remember we said it's a constant represented by D, called the common difference. What we are trying to say here is that if in between two terms, when you have the difference between two terms, the difference between two terms gives us a constant which is represented by D, and we call that constant common difference. Let's take example 1, 3, 5, 7, 9, 11 are sequence. These are sequence. And then we have to subtract each. We'll find the difference between two terms. Let's take example, the difference between the second term and the first term, which is 3 minus 1, will give you 2. That is to say that 2 is the common difference. You come to number 2, you have the first term to be 2 and the second term to be 6. 6 minus 2 will give us 4. That is to say that D, which difference? So we are still discussing on the common difference. Take note, we said that when we have values like 3, 6, 9, 12, 15, you say 6 minus 3 is going to give you 3. So D, which is our common difference, is 3. Then we have 4, 2, 0, minus 2. 2 minus 4 will give us minus 2. That is to say that our common difference here is minus 2. So we're going to be taking some practical question. Take note. Later you settle down to look into the definition, get other alternative definitions, but take note of what we have just said concerning our common difference. So when you subtract different terms, probably the first term from the second term, you discover that you have a constant value. That constant value is what we call common difference, which is denoted by the letter D, a small letter D. Now we're going to be taking some practical question. What is our formula for arithmetic progression? What is our formula for arithmetic progression? What the formula for arithmetic progression is given? Formula for arithmetic progression, arithmetic the formula is given by Tn equals A plus open bracket n minus 1 bracket D, where A is first term. The A in our formula represents first term. Take note. A represents first term. N represents number of term. D is a common difference. So take note, these are common difference. So let's take first term. So let's work on the first term. So first term is given by dn a plus bracket open. Let's assume that first term is 1 minus 1 bracket d, which is going to give us a plus n. 1 minus 1 is 0 bracket d. This is equals a plus 0 times d is 0. A plus 0 is a. That is to say, the first term of any given arithmetic progression is a. A is first term. Then with this, we can practically say that a is equals first term. Then a plus, take note, d equals second term. Why do we say that a plus d equals second term? Practically, let's go. A plus d equals second term. Come back here, take note. Tn equals a open bracket 2 minus 1 bracket d. This will give us a plus 2 minus 1 is the same as 1 bracket d, which is a plus 1 times d is d. That's why we say second term, which is this 2, will give us a plus d. That is to say that third term will be a plus 2d, will be third term. A plus 3d will be fourth term. So how you just take note. The secret is that your term minus 1 will give you the formula. For example, if we say that a plus 3d is fourth term, that is to say that a plus 4d will be fifth term. Fifth term. A plus 5d is sixth term. So with this, a plus 6d will be seventh term, and so on and so forth. Please take note. These are the things we are going to be using to do our work. So we're going to be taking some practical examples. So take note of this. Please carefully watch this. Take note. So our first term is given by a. Second term is a plus d. Third term is a plus 2d. Fourth term is a plus 3d. Fifth term is a plus 4d. Fifth term is a plus 4d. Sixth term is a plus 6d. And then seventh term is given by a plus 6d. Take note, a plus 6d will give us seventh term. We're going to be taking some practical work. Remember, let's make use of the examples of this value we have here. Okay, we want to look at the example below. Find the second term, sixth term of the arithmetic sequence below. So let's take them, look at it carefully. We want to take a sample. So let's look at number 1, solution to number 1. We're asked to look for what? Look at number 1. Take note, we have 2, a particular value is missing here, 8 and 11. We have to look for the second term and the sixth term. So let's go. Second term, number 1 I, or let's use the letter A to make it easier for us, A, and then we call this B to make it easier for us. So 1A is second term. Remember, our second term is given by A plus D. which is going to be first term. What is our first term? 2 plus our common difference. So how do you get your common difference? First of all, you know that this is A plus D. A is equals to D is 11 minus 8, which will give us, which is equals 3. So a common difference is 3. So you write 3 here, which is 2 plus 3 is 5. That is for 1A. Then 1B, that has to do with what? System. Please remember the system. That is 1B. We have that system is A plus 5D. First of all, let's state that our value A equals 2 and D equals 3. So let's substitute. This will now give us A plus 5D is equals to A is 2 already, and then we'll say D is 3. 5 times 3, which is 2 plus 5 times 3 is 15, which is 2 plus 15 will give us 17. So the system of this progression is 17. If you look carefully, is what? 17. And so if you want to do a check, that is to say that after 2, second term is what? 5. And let's check if that is true. We said the common difference is 3. Let's keep on adding the common difference. 2 plus 3 is 5. 5 plus 3 is 11. 11 plus 3. Okay, look at it. Look, 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 will give you 14. 14 plus 3 will give you 17, which is the sixth term. Please take note. Okay, let's look at example 2. Example 2. This is example 2. Take note. First, 2A solution. 2A, we are looking for second term. And remember, our second term is given by T n equals to A plus D. A is equals to 2, which is our first term. Then D is given by 8 minus 6, 8 minus 6, which is equals 2. So let's input into our value now. T n is equals A is what? 2 plus our common difference, which is what? 2. That is to say that our second term is 4. 2 plus 2 giving us 4. Then 2B is sixth term. System is given by A plus 5D. Remember that A is already 2. We put 2 plus 5. What is our common difference? Our common difference D is 2 as well. We put 2 there. So this will give us 2 plus 2 times 5 is 10. 10 plus 2 is 12. So that's for example 2. We'll quickly go to example 3. Example 3. If you quickly look at example 3, we're working at is on example 3. This is the first term. Then the second term is not given fifth term. The third term is given fourth. We have to look for the second and sixth term. So let's go. 3A. Solution 3A is second term, which is given by T n equals A plus D. A is our first term, which is 1, and our common difference D is given by 7 minus 5, which is 7 minus 5, which is 2. So therefore, let's input into our formula now, which is n equals to A, which is 1, plus D, which is 2. This will give us 1 plus 2 is 3. Then 3B is the sixth term. For sixth term, we have that A plus 5D. We already know that A is, which is our first term, which is 1, plus 5. Our common difference is 2. Take note, which is 2, which is 1 plus 2 times 5 is 10, which is 1 plus 10 is what? 11. Take note. So quickly, you're going to do something for me. I want you to look at question number 4, 5, and then, if possible, question number 4, 5, and 6. Then drop your answer in the comment section. So please take notes. Look at question number 4, 5, and 6. Look at question number 4, 5, 6. Solve these questions. Find the second term and the sixth term of this progression, of this arithmetic sequence or progression, and leave your answer in the comment section. Question number 4, take note number 4, 5, and then 6. Take the same format and you will get your answer. Okay, thank you. Please do remember to subscribe so that you'll be notified. Please click on the notification bell so that you'll be notified when there is future upload. So please try to like. We're also on Facebook. Try to comment, like, and then if you're on YouTube, please try to subscribe. Thank you. We'll still get other part of this video. This is just a part of it. We'll get your other series on this particular topic, and please try to tune in to get other part. In case you are joining us for the first time, we still have topics on geometric progressions and other topics. Just go, you'll see other topics there. Try to sit with it, and you'll see that mathematics is not as hard as people believe mathematics to look like. So thank you.